Welcome back to the video series on college algebra. Today's video we're going to be talking about how to find the domain and range of a graph, given the graph, and then you can also apply this to given an equation. If you just graphed your equation, then you would see the picture. So in my last video when I covered domain, I said domain was all your x values, right? So domain is all x values you can use. Okay. Now, just like in that last video, what I said was it's easier, instead of saying what values you can use, it's easier to say, okay, well, you can use everything except for these few, right? Or this value or this, listing those few values that you can't use, right? So the same thing applies here in the graphs. You just say, okay, it's everything, but these values, or it's everything, right? Now there's a different way of writing that, and that's in the notation form, and I'll go over that here in a minute. So domain is all the x values you can use, and I kind of hinted at it, or I covered that in my last video. But range, right, and I'll denote domain as the capital letter D and range as capital R. So range is all y values. Now it's not all y values you can use, it's all y values you get, right? Meaning values that you get out, right? Now for this graph, we have the graph y equals x squared plus 3, okay? So if you look at your graph, you have the parabola y equals x squared, but then it's been translated or shifted up 3 units, right? So if you look at this, there's no holes in your graph, meaning there's no jumps, kind of weird jumps or kind of swoops up or down, which would indicate like a vertical asymptote. So because there's no holes or there's no kind of swoops left or right, and both arms are reaching up in both directions, you would say that you could use all values of any x and you would get a y out. There's no values where if you plug it into your calculator, you get an error, right? Real values, right? So, and you can see that from your equation, y equals x squared plus 3. There's no value, there's no square root function, there's no rational, like fractional, where it make the denominator 0. So those things you kind of watch out for, and you can kind of think, oh, okay, there's something here, there's probably going to be a value that I can't use. But when there's nothing like that, then you will always be able to use pretty much all real values. So in the last video, we just wrote the domain as all real numbers except whatever x cannot equal whatever. But in this video, I kind of wanted to go over a different notation, and it's with brackets and parentheses, and with infinities and stuff like that. So if you ever see this, and you'll see this, so if you have a bracket, meaning 2 brackets, like this indicates values you can use, right? And then parentheses are values you can't use, right? So in this, your domain would be remember, domain is all your x values. So since there's no x, positive or negative, that you can't use, right? You would use your domain as all real numbers, but another way to say that in notation form would be positive and negative infinity, right? So I'm going to put negative infinity. Let me redo that because that's a little too close. So negative infinity. Let's get that right there. Okay. Now, because it's you have positive, negative, infinity. Infinity is just a placeholder. It's not a value, right? Infinity is just a it's a placeholder for a number that's always getting bigger or always getting smaller, right? So because of that, you cannot use a bracket, but you have to use a parenthesis. So your domain would be this, okay? It's a little weird, but once you do a couple of these, you can kind of start seeing it, right? So it's parenthesis, negative infinity, comma, positive infinity, right? Now your range, you have to ask yourself, okay, what y values do you get? You get out, from plugging in a certain x value. What y value do you get out? Well, how you determine this is you say, okay, what's your lowest y value? And so looking at my graph, the lowest y value would be y equals 3. That's at your minimum, right? So you would have y equals 3, right? Now, jumping ahead of myself. So you have 3, and then what's your highest y value? Well, that's positive infinity, right? Now, 3 does exist. There is no hole at 3, so you would have a bracket, and then because you have infinity, you would have parenthesis. Right now, this next example, right, you start seeing this kind of swoop up motion. As you're coming from the left-hand side, it's swooping up, and as you're coming from the right-hand side, it's swooping up. So that denotes that there's a vertical asymptote, and this time it looks like it's at y equals or x equals 0, right? So the domain's going to look a little funky at first. So you remember, you always start with your smallest number. Well, because this line, if you continue your graph and you keep scrolling, this green line, from here going to the left, it's still, you can still use any x value, right? So you would say negative infinity. Now, where do you start swooping up to your first vertical asymptote? And that's x equals 0. So from negative infinity to 0, right? And then so you'd put a parenthesis here because you can't have negative infinity. And then you would have a parenthesis here because 0, your green line never crosses x equals 0, right? It's what's called a vertical asymptote, so it's from negative infinity to 0. And then you would go from 0 to positive infinity. Okay, now there's going to be this kind of funky little symbol, and it looks like a U. Let me see if I can, my iPad's kind of screwing up. Okay, so it's going to look like this, a U. All this denotes, this is from what's called set theory, and this is it's a shorthand way to write the word and. So you have negative infinity to 0 and 0 to positive infinity, okay? That would be your domain. And then if your equation had multiple vertical asymptotes, you would just keep listing these out, putting the U in between each set of parentheses or brackets or whatever. Now, your range, you say, okay, what's your lowest y value? Well, looking at my graph, it also looks like the graph does not cross y equals 0. That would be what's considered a horizontal asymptote, right? So you would put 0, and you would put parenthesis because it doesn't cross it, just like it before. And then where does it stop? Both directions, the arms are reaching up forever, so that would be positive infinity, okay? And so you'd have both of them being parentheses. All right, now what about something that looks kind of something like this, which is considered a piecewise function, right? And so at this upper point, when x equals 3, your y value is 5, right? And then, but you have this hole down here, and then it jumps and it does this little swoopy motion, right? So because there is a dot, there's a filled in dot above, and then there's an open dot, this would be almost considered one graph, right? There's no x, there's no jump, there's no x value you can't use, right? So your your domain would be from negative infinity to positive infinity, okay? And because it's infinity, you'd put parentheses. Now your range, you say, okay, what's your lowest what's your lowest y value? Well, this line keeps going on forever, and this line keeps going on forever, right? So because of that, you would have from negative infinity to positive infinity, okay? And it would also be parentheses because there's you're dealing with infinity. So if you now it would change if you would have a hole there. So say you had this per se, you had the same thing. So 1, 2, 3, 1, 2, 3. It's continued up 4, 5, and so you had at 3, 5, you had a hole, and then it jumped down and fell down here, and then continued, right? So you would have your domain, right? Your domain would go from negative infinity to 3, right? To 3, and it would be a parenthesis, and then from union, and then 3 to positive infinity. Because there's an open hole, you would have a u in between. Let me rewrite that. That's not. That looks u. Okay. It would jump. It wouldn't look like the one before. The reason the one before was from negative infinity to positive infinity because at x equals 3, one of the dots was filled in, so it existed at that point. At this one, you had 2 open dots, so it doesn't exist at x equals 3. Now your range, right? So your range would go from, so what's your lowest y value? Well, because on this left graph, your lowest y value would be negative infinity, so negative infinity, and then what's your highest y value? Well, your highest y value would be positive infinity, right? So the more you do this, the better, the easier graphically it is to see. There are some little tricks to do this algebraically. And if you have any questions, I'd be love to help. Just post them in the comments below, or you can email me in the description, and I'd love to help. Thanks.